Okay, today we're talking about problem 4.1 in Butterflies, Pinwheels, and Wallpaper, CMP3, working with dilations. Okay, now dilations, if you remember, is a transformation that makes a shape bigger or smaller. Okay, a lot of people think dilations were just making shapes bigger. Dilation can actually make a shape smaller as well. Keep in mind, even though we make a shape bigger or smaller, okay, the shape will still be similar. Okay, so all the angles are going to stay the same. When we work down through, and as we get into 4.1a, okay, it says, draw the image of quadrilateral PQRS after a dilation with center 0, 0 and a scale factor of 3. Label the corresponding points P', Q', R', S'. The scale factor is key whenever we're doing a dilation because that is going to dictate how much bigger or how much smaller the shape is going to get. When you hear the word scale factor, you should immediately think of the operation of multiplication. Okay. Whatever the scale factor is, essentially all we're going to have to do is multiply our original coordinates by that scale factor to get our new image. Alright? So let's go down and let's complete this example. The first step in completing a dilation, we'll call it steps to dilation, alright, is to first label the vertices. What I mean by that is this. If we go down to our shape, we see P is there, S is there, R is here, and Q is here. In order to figure out what our bigger shape is going to be, we need to first know where these shapes lie on our graph. So let's label these. We'll start with P. If it helps, some like to show that we start here, we trace down to our X. Okay, the X coordinate always comes first when we label our vertices. So the X would come first, so P would be 2, Y would be 4, so point P would be 2, 4. Alright, we're going to do the same thing for S. We're going to do the same thing for Q. We're going to do the same thing for R. Okay, so what you should be doing now is we should be finding where are these vertices, and then we're going to label them. So S here, we go down to 4, 4. Our point for S is 4, 4. Q is going to be here at 2, 2. R is going to be here at 5, 2. Okay, note that this is going to be 5 because it's in between 4 and 6. Okay, in between 4 and 6, it's just going to be 5. Now, we talked about the scale factor earlier being key when we answer questions about dilations. Okay, we also said that scale factor normally is going to mean multiplication, and it is. So, when we figure out where our new points are going to be, what this scale factor is doing is it's going to tell us that it's going to get 3 times bigger. So we should expect to see a shape 3 times bigger than this original one. So, knowing this, we have to take each one of these vertices and multiply it by 3. I'm going to start by multiplying 2 times 3. 2 times 3 for P' is going to be 6. 2 times 3 is 6. 4 times 3 is 12. So P' is going to be at 6, 12. S', 4 times 3 is 12. 4 times 3 is 12, so S prime is going to be at 12, 12. Q prime is going to be at 2 times 3, which is 6. 2 times 3, which is 6. Q prime then falls at 6, 6. R prime falls at 5 times 3 is 15. 2 times 3 is 6. R prime falls at 15, 6. So let's go ahead and plot these points. P prime is going to be at 6, 12. So let's go ahead and plot. We go over 6 up 12. P prime will be here. Apologize, it keeps wanting to go away on me. S prime at 12, 12. So I'm going to go up here, over here. 12 prime, or 12, 12, excuse me, will be where S prime is. Q prime is going to be at 6, 6. So I go over 6, up 6. It's going to be here. Q prime. And R prime is going to be out here at 15, 6. Okay, notice this is our X value. Okay, even though the number 15 is not on our graph, we can still make, okay, a mark here. We can extend it out 15, 6, out 15, up 6. And this is where R prime is going to fall. When I connect my points, this is what I end up with. Okay, you will note that this shape is exactly the same as this one. However, it is just bigger. Alright, it's just a bigger shape. All the angles are the same. All the angles inside here are the same. All of these angles are the same. The only thing that changed was the side lengths of the figure. Let's get into the questions. Number 1, how do the side lengths of quadrilateral P prime, Q prime, R prime, and S prime compare to those of quadrilateral PQ, RS? This question is talking about the side lengths. The question is asking you about the side lengths of a figure. The first most important thing to know is what the side lengths actually are. So let's go up into our original figure and let's try to get an idea of what the side lengths are. The side length of PQ is going to be 2 units. So we can mark that as 2. The side lengths of QR is 1, 2, 3. And the side lengths of PS is going to be 2. The most confusing thing for students here is they want to count the lines here at PQ, but when you look at it, PQ is only 2 units long. So we're going to label that as 2. This is 3, 2. We're not going to worry about this side SR for right now. Let's take a look at Q and R. Okay, Q prime and R prime, excuse me. So look at how many units long this is. We count it. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. P prime, Q prime is 1, 2, 3, 4, 5, 6. P prime to S prime is 1, 2, 3, 4, 5, 6 units as well. I'll erase these units here so we can just see a little bit more clearly. But when we look at these units, okay, we're going to first off compare corresponding sides. We're going to compare this side to this side, this side to this side, and this side to this side. A key in math when we're talking about comparing side lengths, oftentimes we look for a pattern or a way, an operation that we got this number to this number, this number to this number, this number to this number. When we look, the only pattern that makes sense is multiply by 3. If we took each one of these sides and multiplied it by 3, we would get the corresponding side on the dilated figure. For example, if we took 3 times 3, we would get 9. 2 times 3 would get 6. 2 times 3 would get 6. Okay? we can kind of guess without knowing what this side length is, that if we multiplied whatever this side length is by 3, we would end up with this side length. So what we're going to say for number 1 is the side lengths tripled in size. The side lengths tripled in size. Okay. Another way to write this exact same thing, and you can write either one, the side lengths were 3 times as long. The side lengths were 3 times as long, indicating that it's going to take 3 times to get to the new one. Okay, we got that from our scale factor. Number 2 is how do the angle measures of quadrilateral P', Q', R', S' compare to those of quadrilateral PQ, RS? We already talked about how the angles of these shapes stayed the same. The angles here are the exact same angles as these up here. Okay, if you look at this angle here, angle Q, that's a 90-degree angle. Q' is also a 90-degree angle. So how do the angle measures compare? Well, the angle measures stay the same. Angle measures stay the same. When we talk about 3 and 4, we have to remember some vocabulary. Okay, perimeter. Perimeter will be all of the sides of a figure added together. So it's all the way around the outside. Okay, what it's going to ask us to compare the perimeter of our first figure here to our perimeter of this figure here. Now, understanding that we don't know this side length, we can't determine the exact perimeter. But if you know that all of the side lengths tripled, all the side lengths increased by 3 times, they're 3 times as long, you know that the perimeter, okay, we can write here, the perimeter will be 3 times as much. Or 3 times bigger. Than the original figure. When we talk about area, area is all of the squares inside. Now, when you look up here, you'll notice that these squares on the inside, some of them are not going to be totally filled in. If we count up, we have 1 hole here, 1 hole here, 1 hole here, 1 hole here. Now, you could take this little triangle and kind of rotate it around to add a new one, but what we're going to do is this. We're going to make a brand new rectangle here. This rectangle here would be 2 units if it wasn't cut off. However, we only have half. So it's really 2 divided by 2. Alright, 2 cut in half will be 1 whole one. So the area here is 5. I'll give you a hint, the area here is 45, which means that the area increased by 9 times. We're in step 5, and the rule for this is 3x, 3y, indicating both were multiplied by 3.